all know that I'm pretty much flawless, right? So when earlier this year the planets lined up against me and I somehow failed to make a backing plate for this collet chuck here, it was obviously the fault of the tools I used. After all, I'm flawless, according to my mom. So the old tools were banished from the tool temple and given a one-way ticket to the smelter. And here are their replacements. Two sturdy tools for internal turning operations, both 20mm thick, so they should be able to handle a bit more stick out than the old tools. But there's one problem. They don't really fit in my four-way tool holder. Well, they might actually fit if you screw the screws all the way back, but the screws are not pushing down on the flat, and you are not able to shim the tool to the right height. So guess what I'm making out of this block of scraptonium. And if you guessed wrong, you probably should stick to cooking channels or cat videos. Not that there's anything wrong with that. This tool comes with one insert, this one with none, but I'm already using this size insert, so that's not a problem. And I bought a nice supply of new tool tips, because you might have seen me go through quite a few of these when using the sliding spindle lathe for threading. Alright, enough about these. First thing I need to do is drill a hole through here. So let's go to the lathe. It took me a while to get this block of steel centered. Unfortunately, my dial indicator doesn't have enough travel to go around the corners, but I think I now got it running within a few tenths. Next I need to drill a 10mm hole, and I cannot believe how poor all my 10mm drill bits are looking. 3 out of 4 have shank damage from spinning around in the drill chuck, probably on the electric hand drill. All 4 have been reground, except maybe this one. It's still black on top, so that's still the original coating. Some of them have flute damage, and what's really hard to believe is that this bright one seems to be the best drill bit I have, and that came out of that rather poor Banggood drill set I tested last year. If I ever start making some real money with my YouTube activities, I'll buy myself a new set of drill bits that won't get used on the electric hand drill. Although I'm pretty sure all of these will still drill a hole. For fun, let's regrind the poorest looking one and use that. Well, I am certainly not a drill doctor, but most of the drills I grind do actually cut a hole, especially in the 5 to 15 millimeter range. Below or above it usually gets more difficult, but I have been getting better at grinding drills over the past couple of years. Hopefully this one will also work. Alright, enough excuses. Let's see if I did a good job. And I'm through. I think that was pretty good. The chips didn't clear the flutes when the drill got deeper, but at least it was cutting on both edges, which isn't always the case when I regrind a drill. I guess I didn't spend that extra time honing this drill bit for nothing. This here is a 13mm drill bit of Chinese origin. I used this drill bit a few times and it was always seizing up in the hole I was drilling. I did regrind it, but I never found out why it was always binding up. So I just cut off half of the flutes and ground a 45 degree angle on there, and now I'm going to use it for chamfering. Okay, let's see if it will have a successful career as a chamfering tool. Good enough for me. Next I'm going to turn down this side to just under 3 centimeters, so it will fit inside this hole on the compound slide. I've ground a new left-hand high-speed tool bit. Hopefully it won't burn up. I'm going to be running at 350 RPM, and I have the carriage locked down, so I will be feeding in with the compound slide. I think I'm ready to go, so let's do this. All those tiny hot chips are hitting my hands. Pretty annoying. Not bad. Actually pretty good. Alright, I'll take a few more cuts till 4 or 5 millimeters deep. No more, because then there won't be enough material left on the other side for the set screws. I just touched up the tool bit, because like every high-speed tool bit I ever used, it always gets dull. Well, let's continue this hot chips bombardment. Still not cutting great. Maybe a lighter cut. Well, it looks and sounds sharp. I just resharpened the tool bit, but I'm not getting the finish I would have liked. I'm down to 31 millimeters, so 1 more millimeter to go. Then I'll remove a bit over here so the block of steel won't be resting over there, and then I'll try to get a better finish with a round nose tool. This sure isn't the easiest material to cut. That definitely feels a lot better. I got some chatter when I pushed the tool a bit too much into the corner. Yeah, it doesn't matter. It's on the bottom side, so you won't see it. Well, that's too bad. It doesn't fit. I made this part too long. The hole is 4.5 millimeter. I made this about 4.8. So back into the forge jar it goes, and then I'll skim off a couple of tens. That even makes it look nicer. Too bad it's on the bottom end. It's running a bit wobbly, but that shouldn't matter. I guess I'll have to chamfer that by hand now. Anyway, that should be enough. Feels nice. I was running the lathe at 500 RPM. Now that the workpiece fits onto the compound slide, it's time to make some holes. And I've already lined up the workpiece with the spindle using a square. So let's start drilling. I've lined up the marks and the spindle and the drill chuck arbor as good as I could. This will be the first time I will be using this tool. So let's see how much run out it has. Well, that looks pretty much the same as when I turned the arbor on the lathe. So that's a good thing. The hole I'm going to drill here has to sit 15 millimeters from this side. One turn of my cross slide is 2 millimeters. This pin here is 10 millimeters thick. Half of that is 5 plus 15 is 20, and that means I'll have to turn the cross slide 10 full turns. Well, let's face it, this drill bit is just too short, so I'm going to switch to a long drill bit. I didn't start with this one because I was afraid it might flex. Why is it that drill bits are either too short or way too long? I wouldn't mind something in between. I need to drill this hole to 20 millimeters, but to go from 4 millimeter to 20 millimeter, that's probably too much, especially with this tough material. So first I'm going to use a 11 millimeter drill, and this is not a cheap Chinese drill. This is one of a few quality drills I have, made by Phantom. Found them at a flea market. And they drill a lot better than those cheap Banggood drills I tested out last year. Still running at 550 RPM. Maybe a bit fast. Maybe not. That's becoming a bit dangerous, even for me. I'll just put on my safety glasses. Some say I should have done that already. Well, this is annoying. I think I will need to move to woody woodpecker drilling. Oh, what's a good drill good for if you end up with this shit? Do chip breaker drill bits exist? If not, somebody should invent them. Next I'm going to drill a 19.5mm hole, and then I'll ream it out to 20mm. I bought this from eBay UK, and the price was reasonable. Even the shipping wasn't too bad. I guess that will change once Brexit kicks in. Made by Irwin, just like that Australian bloke that got eaten by a fish. Never heard of the brand, but we'll see if it will drill. I've slowed down the lathe to 210 RPM. Here we go. Nice. And there we go again. It's getting a little hot. I'll shoot some oil into the rear opening. Done. That's a nice and smooth hole. Let's take a measurement. Ha! 19.5mm. That must be one good drill. Most drill bits I use normally drill an oversized hole. I got here a brand new reamer, so this is going to be its first hole. A bit of loop might help. Let's see if it can get it done. Running at 115 RPM. This reamer has a spiral that curves to the left, so it pushes the chips forward. No need to pull it out and put it back in to clean out the chips, like with a drill bit. And it's done. I had to turn around the workpiece because there's not enough travel in the crosslight to get to this side of the workpiece. This time I didn't use a square to line things up. I just used the front of the chuck, and that should be good enough. Anyway, now I have to go to the same drilling and reaming process, but this time for a 16mm hole. After that I will stop this video because it's getting long enough and I'm not getting it done this week. So I guess this video will be continued in part 2. I almost forgot to mention how this Allen head bolt or screw, whatever, works. So you turn it to the right and you lock up this nulled part. Turn it to the left and it's loose again. It's that simple. You cannot see the bolt on the inside where the jaws are, so I have no idea how it works, but work it does. But to be honest, I'm not sure if it's really useful. Maybe it is useful on a hammer action drill.